Molecular geometry. Valence shell electron pair repulsion, VSEPR, is a model that predicts the geometry of the molecule from the electrostatic repulsions between electron pairs. Let's look at the case where there are two atoms bonded to a central atom. There are no lone pairs. The electron arrangement is linear. The molecular geometry is also linear. An example is beryllium chloride. Bond angle 180 degrees. With three atoms bonded to the central atom, no lone pairs, the electron arrangement is trigonal planar, the molecular geometry is trigonal planar. Boron trifluoride is an example with bond angles 120 degrees. With four atoms, the electron arrangement is tetrahedral and the molecular geometry is tetrahedral. Methane is an example. The bond angle is 109.5 degrees. Five atoms bonded to the central atom. Again, no lone pairs. The electron arrangement is trigonal bipyramidal and the molecular geometry is trigonal bipyramidal. The bond angles are 90 degrees axial and 120 degrees equatorial. Phosphorus pentachloride is an example. With six atoms bonded to the central atom, no lone pairs, the electron arrangement is octahedral and the molecular geometry is octahedral. Sulfur hexafluoride is an example and the bond angle is 90 degrees. How do lone pairs affect the geometry of the molecule? Notice the difference between methane, ammonia, and water. In methane there are no lone pairs and the bond angle is 109.5 degrees. In ammonia there is one lone pair, bond angle is 107.3, and two lone pairs in water decreases the bond angle to 104.5 degrees. It seems that the lone pairs have a larger volume requirement. Let's see the effect of adding lone pairs to regular geometry. Here we have the case of two atoms bonded to the central atom. The number of lone pairs is 1. The electron arrangement is trigonal planar, but the molecular geometry is bent. Sulfur dioxide is an example. With three atoms bonded and one lone pair, the electron arrangement is tetrahedral. The molecular geometry is trigonal pyramidal. An example is ammonia. With two atoms bonded and two lone pairs, the electron arrangement is tetrahedral, but the molecular geometry is bent, as in the case of water. With four bonded atoms and one lone pair, the electron arrangement is trigonal bipyramidal, but the molecular geometry is described as a distorted tetrahedron. With three bonded atoms and two lone pairs, the electron arrangement is trigonal bipyramidal, but the molecular geometry is T-shaped. With two bonded atoms and three lone pairs, the electron arrangement is still trigonal bipyramidal, but the molecular geometry is linear. With five bonded atoms and one lone pair, the electron arrangement is octahedral. The molecular geometry is square pyramidal. Four bonded atoms and two lone pairs, again, electron arrangement is still octahedral, but the molecular geometry is square planar. How do you predict the molecular geometry? First, draw the Lewis structure for the molecule. Count the number of lone pairs on the central atom and the number of atoms bonded to the central atom, and then use VSEPR to predict the geometry of the molecule.